before we go into the sort of technical nitty-gritties, because I want to keep this as in the weeds as possible and really look at the technologies. But let's look a little bit. What are the pain points that you usually have if you're looking at platform engineering? Just to recap this, what are the value drivers? And I think what resonated a lot when we spoke earlier was that you also see platform engineering as a multiplayer game with pain points both from developers and operation teams. Can you highlight a little bit what are the usual problems that you see and that you've solved in your career that where you think okay, the platform engineering is the answer?
Sure. So, if we break it down, maybe let's approach it this way. We can talk about both sides of that slide, the infra side, the ops side, and then the developer side, but then talk about as we go further up the pyramid where they coalesce, right? So from an infrastructure perspective and an ops perspective, delivery and getting infrastructure out to consumers has always been a challenge, right? Thinking back to when prior to cloud, when it was on-prem data centers, and there was tremendous amount of lead time for ordering hardware, getting things racked and stacked, cabled, networked, appropriate operating systems installed with the correct patches. So many things had to happen before that infrastructure was turned over to somebody who wanted to use it. And when I say use it, I mean host the application that they were developing on it or use it to develop an application. It took forever. The promise of virtualization in the data center and then ultimately cloud was that a lot of that could be shifted left and put into the hands of developers to control. While that's certainly true, in a lot of enterprises, that causes quite a bit of friction around standards and how things are delivered versus how much freedom you give to non-infrastructure teams to be able to deliver stuff. One of the answers to that is having some self-service capabilities in a platform. So that's definitely one of the things that platforms solve for, right? It's giving developers guardrailed self-service that lets them provision infrastructure. That's one part of the story. From an operations perspective, if you shift too far left and you have teams that are creating infrastructure and doing things in a non-guardrailed fashion, operationally, when things break, it becomes a nightmare to troubleshoot, right? Having a platform in place helps, give the operations team a framework that lets them do their job effectively and quickly, lets them troubleshoot, get in there, resolve issues in a timely manner, right? That's one of the biggest boons to operations when we're talking about platforms.
Yeah, and that's the thing, right? I think if you look at this, self-service is obviously the thing that you want to hit, but those components of standardizing the things that you have, automating, and sophisticated automation is so important. And then it's also just so important to realize that you don't do platform engineering for the sake of platform engineering. We're ultimately simply serving the organization to bring more features to market faster. Like that's the race we're in, right? Innovation
Correct.
up.
Yeah, definitely, right? I mean, developers want infrastructure faster so that they can ship what they're developing faster to impact the business, right? And please the customer. That's really the name of the game. That's what it is. You want to be able to put developers in a situation where they can iterate quickly, get new ideas out there, pull them down quickly if they're not working, and you don't want that to be a huge cognitive load for them or for the infrastructure and operations team. You want that to be something that kind of just becomes normal, right? You want that to be just part of your day-to-day activity. It shouldn't be something that you need to step out of your comfort zone to achieve.
Absolutely. And so this is why, and we're now making that sort of step into the design of platforms. It's so important that you actually see this as a multiplayer game. So, and that is what I think a lot of platform engineering teams get wrong at the moment. They are designing single player. And so one of those single player games that has a sort of, you're just optimizing on one persona is what we call infrastructure Tetris. It unfortunately doesn't exist. We should 100% build that game. But it essentially means you have a platform where, you have a fancy portal and that has nothing, like, this is not a critique towards the portal. So I want to get that very clear. Like, this means you're abusing the portal, because the portal is a presentation layer, good at what it does. But if you misdesign your platform and you have developers that are just, pressing the scaffolding button over and over again, and then you have that huge bucket that is with an infinite bottom, never stops, and you like click, 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 and create an infinite amount of resources, then the developers are maybe happy, but the infrastructure groups are completely depressed because they are the ones that have to go into this bucket and say like, hey, this still, very cute configuration for memory store in production, but also incredibly dangerous. And we have to update this and maintain this. So it's really just important, if it comes to architecture design, that we are thinking about these things early on. So maybe, Paul, how do you think about designing platforms? What are the principles that you follow if you're designing platform? Then we can actually become more applied here.
Yeah, definitely. So, just quickly looking at this slide, I will just say golden paths are really the thing for me that when you get to the point of your platform development, that you're delivering golden paths that are directly related to asks from your development teams or your customer teams, whoever's consuming them, and you're delivering those golden paths to them in a way that they find consumable. That's when the value just skyrockets, right? That's when your platform really starts to show value. What I like to take into consideration here is really, starting small. So I really believe in, I know you talk about this a lot, Gaspar. You talk about the MVP, the minimum viable platform. I really believe in that as well. I think that it's very important to, show value by quickly iterating on your platform, but also making sure that the teams that will be consuming the platform are part of the story. Back to your multiplayer game piece, right? You can't do this in isolation. Infrastructure teams can't be doing this on their own, and development teams can't be doing this on their own. It needs to be kind of a joint effort. Kind of like if you think about team topologies, right? And think about how a lot of that is laid out from an organizational structure. That's kind of what you want. You want to have enabling teams. You want to have feature teams. You want that capability to exist when you're designing your platform. The other thing I'll say is not every component of your platform needs to be infrastructure focused, right? There's a large amount of your platform that provides value via documentation in a standardized way, an automated way. So, taking some of that cognitive load and toil away from developers and infrastructure engineers to document things and just have that generated automatically in a dynamic way. Huge win, huge win. And that's something that in a lot of cases can be pretty easily achieved early on, right? And that's not infrastructure focused. The other self-service infrastructure focused, at least. The other thing that I find really interesting is being able to provide visibility into certain metrics around your platform. So whether that's looking at things through the DORA lens around your delivery of software, or if it's more around looking at things and servicing vulnerabilities in running applications, vulnerabilities in code bases, things like that, getting that into a platform for visibility for everybody to see, I think is a very important design principle.
Yeah, absolutely. Couldn't agree more. And on the MVP thing, the thing that always strikes me is that, and that's really something that I'm spending so much time on at the moment. How can you I think it's sort of, yeah, maybe not established, but I'm always like, of course, we build an MVP. And then the next question for me is always, okay, you have that MVP. How do you get that first team to jump? They're like,
Right.
always feels like this, these
Well,
in Iceland, these penguins, when they're sitting there and one has to jump first because there's a sea lion below and some will die. So I'm always wondering, like, okay, how do you get the first product unit to say, okay, well, I'm jumping on the platform?
yeah, I have some experience with that. So, one of the things that I've seen work there, again, is really making sure that you have a team working with you from the beginning, right? you need to have some level of sponsorship that goes multiplayer, multi-team. Again, you can't just have sponsorship from an infrastructure perspective. You can't just have sponsorship from a product team perspective. You need to have sponsorship on top of that that says, why don't you look, this team is struggling with X, Y, and Z. Why don't you work together, build an MVP that solves at least X and get them to start using it for X? And after that, honestly, if you're successful with that, we see pretty quickly that team wants to solve Y and Z as well. And you start doing demos, you start doing show and tells within the organization, you start communicating things, and the value that the platform brings then gets exposed to other teams, and you start onboarding pretty quickly.
Yeah, that's interesting, right? There is this inflection point. The first team is running all of its stuff in production through the platform. And once that happens, it's like click and it's like, and you are scaling.
Exactly.
Nailing that first team, and yeah, that's a super interesting point. Good. So let's actually, because I feels like there's so much to cover. What is this? Yeah, there's so much to cover today, that I'm excited about. This is the design of an internal developer platform that you and I and a couple other colleagues worked on for our larger session in beautiful Las Vegas. And so I want to go through this quickly. And actually, this exact design is one that we're really people built with us a lot. It essentially looks like this. Some of the logos change, but they're all
Exactly.
surprisingly similar. We have the developer control plane, which is a little bit of a misnaming because it's the interaction of all stakeholders with the platform. You have the portal and front end layer, essentially the front end of a platform. You have the version control system and we can look into this a little more in a second, where you now have differentiation between workload source code and platform source code in IAC, where workload source code is really about the workload source code, and then an abstract description of the world, which here in this case, a workload specification with SCORE, an open source project we've just donated to the CNCF. If anybody from the CNCF is listening, please accept the donation. And for everybody else, please ping them on Twitter. And then for the platform source code, we have, pre-baked Terraform files, resource packs for Google, etc. Integration delivery plane, CI pipeline, and then the orchestration system, which is essentially a graph-based backend for platforms. We can cover that in a second. But if we look at, then obviously monitoring and logging, security, etc. If we look at the resource plane, we zoom in a little more on this, Paul. What is the lowest common tech denominator that you usually see teams focus on, and what's your recommendation there?
GKE.
Yeah.
So by far, right? I mean, GKE is the choice of building platforms, right? On Google Cloud. If you're talking about organizations that are looking at doing like data center transformation or large scale lift and shift, obviously they have heritage workloads that they're looking to move over, and that stuff's really not container focused, right? But when you're looking at teams that are building net new platforms, or they're building platforms for workloads that are running in other containerized operating environments, GKE is really the place that all the action happens, especially now with the introduction of GKE Enterprise recently and some of the features that are in there, config sync, config management, fleets, the ability to have this standardized approach to deploying namespace identical clusters across regions, across your environment, and managing that through GitOps is really where that infrastructure platform magic happens at a runtime layer.
Yeah. And I don't want to out myself as a GKE fanboy, but of all the distributions, it's from the development quality and from the product quality, in my personal opinion, superior to most other, and really also an investment focus at the moment, or continues to be, right?
Yes, definitely. I mean, that is something that we focus on tremendously from a runtime perspective, and Well, let me preface this. You weren't going to come to a talk with somebody from Google and not hear the two letters AI, right? So, with all of the AI buzz and workloads that are happening now, GKE is really the place to be doing your training and your serving of those workloads if you're doing it at scale and you're a Google Cloud customer, right? Like we have a lot of traction there. People building ML and AI platforms on top of GKE from both an infrastructure perspective for training, but also for serving.
Mm. Yeah, yeah. I do observe that, and I can absolutely imagine. Now, if we're looking at this platform, it's obviously, not completely intuitive how these things fit together. So I want to walk through that very quickly. I think the important principle here in the design of this platform is that we are introducing separation of concerns. And that is your former colleague Kelsey just said in a conversation with me, the beautiful sentence, silos are amazing. No, silos are fantastic. So this is going to be like an interesting conversation at Platform Con that I really recommend everybody to watch. But I think what he means is that it's like golden paths should be designed in a way that the only conversation you have between your developers and the infrastructure teams is a conversation about something that's new, right? Something that's established. Like I need a new namespace. That shouldn't be like a conversation. Like
Exactly.
Great API, and you're good, right?
That shouldn't be a conversation. It shouldn't be a ticket. It shouldn't be a Jira. Like that. That's not that. No. Like no. That's something that we've solved for, right? At this point.
And then we have, and that should be gone. And so the design that we have here is to say developers essentially describe what they need. If you look at zoom into the workload repositories, you strip them of the usual configs. So there's no app configs, no infra configs. It's replaced by a workload specification. And again, workload specification score here, which is an environment agnostic way of describing the relationship between the service and its dependent resources. We have a service of named product service here that depends on a Postgres, S3, and DNS. And in this world, we're not saying, hey, this should be this Cloud SQL or this name, or go to that namespace or whatever. We're just saying this is the general nature of things. Now, this runs local by running score compose. It will be running on your local machine. And then you say, okay, I need this for staging. It needs to be translated into the Google world. And that sort of translation happens through, we need rules to do this. So in this case, we called resource definitions. Resource definitions are a way to say if the developer requests a infrastructure of type Redis, or the deployment contains this, and I have to check whether I need to update this, and I have my criteria environment type equals staging, then I would want to use this parameterized infrastructure as code, in this case, Terraform file, to update or create those resources. And we're working and have released something that we call resource packs for Google, for GCP. And so those are essentially individual resource definition that can act as components and Lego blocks for your golden paths, if you want. Like your little Lego golden path can be paved by this. And so then if we bring this together, that's actually done by the backend of your platform. And that's what an orchestrator is for. So you have your infrastructure and operation teams that define the rules for staging, and Postgres use this. And we want to make sure that we have OTel sidecar containers and we have memory store, etc. The developer sends the abstract request through your UI, CLI, API, through SCORE, whatever you want, hits the orchestrator. The orchestrator analyzes the metadata and says, okay, we need this resource definition, and then creates a resource graph, one for every environment and every deployment. And that means in this world, if we have self-service, the developer just needs to say, I need cache of type Redis, 2 lines of code, flies through the system, identifies the right resource definition, and then creates the next resource graph. Graph-based, because that means we don't need a huge amount of different code. Like alternatively, you would do this in Argo workflows or something. That is okay for smaller setups, but at scale, it's becoming almost impossible to do that many-to-one relationship between the workload-dependent resources. In this world, the infrastructure team can say, let me update my definition for memory store. And that means all graphs that consume this will auto update with safety nets, etc. And that gives you that incredibly high degree of standardization and ease of use here, again, being a multiplayer game.
I just want to jump in real quick. That's one of the, earlier when we had the pyramid slide up and we were talking about the two sides. From an operational day two perspective, having that capability, right? Think about, you know, uh, uh, I don't know, one of the last Java vulnerabilities, right? Being able to have a mechanism in place that allows you to go out and touch infrastructure and running applications at scale across your entire estate by editing a few files and ensuring that that's picked up, whether it's on the next deployment that happens naturally via the application team or you're triggering a forced deployment. Having that capability is incredible.
Yeah, yeah. This is such a game changer. It takes a little bit of a new way of thinking about it because of that change of you have a many-to-one relationship, workload to resource definition. But once it clicks, it's really like a mind-blowing impact. And then you could put a UI on top and aggregate data. And you just launched App Hub.
Yes,
I know that the team is already doing sort of lots of additions to this. It's essentially a little bit of a front-end aggregation layer for a platform. What is this about?
correct. Yeah. So, App Hub is kind of the vision for how we start thinking about things in an application centric way rather than an infrastructure centric way. So, being able to ring fence all of the components of your application, whatever that might be, whether that's the container images themselves, the load balancers, the actual runtime, the databases, the data stores in GCS, the data stores in BigQuery, wherever they might be, being able to ring fence that, apply policies in a consolidated fashion, and also surface that and you know be able to apply, like you were just saying, be able to have that one to many relationship where you can say, I want everything that's part of this quote unquote application to pick up this change, right? I want everything that's part of this application to pick up this standard. This is the direction that we're going in with this. This is what this is all about.
And I think, and I've met the team behind this
Mhm.
in Vegas, and was really impressed by the sort of vision for the future. This application-centered model is something that very much resonates with me,
Yeah.
because you can then actually build that, that essentially that graph. It's, I think, the foundation, if you do it well, for intelligent connections to something like Gemini. And so I find that very appealing.
Yeah, it's all about surfacing context of your components, right? So, what is this component? Here's an example, right? I have a load balancer. I have a external load balancer deployed, and that's front ending a controller on a GKE cluster that's serving like 10 different applications, maybe, right, in a
Yeah.
namespace.
Yeah.
Being able to identify that and understand that that load balancer is really impacting 10 applications, and if you modify that load balancer you're going to impact those 10 applications, or if you want to impact those 10 applications you can do it at that load balancer. It works both ways, right?
Yeah.
You have that context,
Mm.
and it's built into your cloud environment. It's not something that is external to the cloud environment. So ultimately, this is something that will be pervasive throughout all of the services and will be consumable throughout all of the services.
Yeah, yeah, yeah. I really, I'm a big believer, and what I really like is that Google is putting so much attention and effort into platform engineering and how to, intelligently combine these things and collaborate with with the ecosystem, and also really understands that, people have their existing tools and brownfield
Yeah.
approaches, and it needs to fit in there. And so I think that's a big strength here. And that is what allows you then to build these golden paths, right? If these things fit together, and again, multiplayer golden paths, things like I need a new resource for something that's already there and it has to be optimally integrated. Secrets have to be injected. It really has to be a high degree of automation. Ephemeral environments, you just mentioned those namespace functions. I've just had a case today around multi-cluster, multi-region system setups that directly benefit from this. Fleet update for infrastructure resources,
Yep.
diff, the documentation bit that you mentioned, the sign-off components, right? Just really meeting the reality of the enterprise where you still have a service now ticket to a security guy at the end because they want to make sure it goes through production, right? All
Exactly.
those things have to be in sync.
Exactly. Yeah, being modular and being kind of component agnostic in these areas is very important to us, right? And that is something that we do strive for.
Yeah. Cool. I want to take a quick look before we take questions into something that we've actually set up. So we've actually, so this is not a wonderful graphic, but it's also a reality that our customers use. Obviously, also a reality that we demo a lot. I want to say one thing, like this is a reality for large customers, right? So I sometimes have GKE accounts with 20 developers coming, and then my recommendation is always, this is like heating your home with an atom reactor. It's totally possible, but probably slight overkill. But if you're at somewhat considerable scale, over 50 developers, I would say this is definitely a cool way of looking at it. And I want to zoom into such a workload source code repository here. Our like a favorite demo setup for Paul, and he's laughing already, is the hipster store. I'm a big fan of the hipster store.
Online boutique.
The official wording, okay, let's stay on the official voice line, the online boutique. And so if we go
Previously known as hipster show.
previously known as hipster, okay, yeah, no, it's important to stay on corporate jargon. So if we go in here to one of the, so this is actually, so the entire thing, I think has 11 microservices, and this is now actually set up for this platform separation of concern world. If we go into the front end here, we see the score YAML file, for instance.
Yeah.
And so what you can see here is that, this is my front end, fine. But you can see the readiness probes, the variables, the resources that it consumes, the relationship to other services, maybe certain sort of security posture we're putting in here. And what we can see is that we're staying environment agnostic, right? So that's sort of the key thing here, separation of concern. You can throw that file against your local setup. You can send this against your staging setup, and the backends will model that in a way it will then actually is actually consumable by the GCP API. Is that a correct way of thinking about it?
Definitely. I think that having a layer like score inserted here really does help keep things modular, right? Because not only are you able to kind of write this definition once, but then swap out the individual components, even if you are on Google Cloud, right? Let's say today you're using one service and tomorrow you want to use another one to achieve the same thing, or you're running an in-cluster database and now suddenly you want to run a Cloud SQL database instead. It's all in one place still, right? You're not faffing around in different areas trying to modify configurations for different things. It's all defined in a central repository. Yeah, so I definitely like this.
And another thing is, to give a very tangible example, so of course the infrastructure requirements change by environment, right? So for instance, horizontal pod auto scaling, something, great for production, and you can totally use it in dev, but it just doesn't really change it doesn't change anything. It doesn't even make your telemetry better to forecast production behavior. It just costs you a lot of money. And saying, okay, well, we are actually going to fine tune the resource definitions in a way where we say, okay, for dev, like even if developers go all in on horizontal pod autoscaling, we're probably going to enforce that we're tuning this down a little bit. And then in production, okay, fine, we're going to use the full load.
Let's not be so aggressive.
Yeah. And another thing is security posture. Like, how do you, like, what are the security components you want to have in labels and annotations? Big problem. Like, how can you attribute costs on an application level to make sure the apps and the labels and annotations follow a certain convention standard? Making sure sidecars for observability components are in, all of those wonderful bits here.
Yeah.
Cool. I would say we can take a few questions, Maria, and see whether there's anything we should go into more detail. And we can already have a look here. So, guys, if you have questions, please feel free to shoot them.
I see in chat, I see Jinto has 2 questions.
Fantastic.
Yeah, I can take
Want
that
me to
first.
read it out so that. Yep. So, okay, cool. Whatever I have read about IDP, everything revolves around Kubernetes in the resource plane. Do I really need to have workloads running on Kubernetes? And can I have an IDP that work with other GCP services like Google Cloud Run or App Engine?
Yeah, I can definitely take that. So, yes, you can definitely have workloads that are running outside of GKE. GKE is not the kind of requirement to have a platform on Google Cloud. It is a very popular way to have a platform on Google Cloud, but it's not the only way. In fact, if you are interested in that, at Next, a few months back in Las Vegas, which is our annual conference for Google Cloud, I had the opportunity to present with a customer and our professional services team about a platform that was built specifically for Cloud Run. Had no Kubernetes pieces to it at all. So if you go on YouTube and look up that talk, I can also provide a link after the fact. You can see about a platform that's totally using Cloud Run as the runtime and doesn't have any Kubernetes engine at all.
Nice. And next question, in the IDP example that you are demonstrating, would developers need to now learn a new technology SCORE?
Do you want to take that, Casper? Do you want to talk about SCORE a bit?
I can, sure. So the answer is, the answer doesn't need to be yes. Like, this is just, I'm a big fan of giving developers interface choice. Some like to use a CLI to do this. Some like to use an API. Some like to use ClickOps. Some like to use this like a code-based thing. The beauty of SCORE is that it's incredibly easy because it's essentially taking Docker Compose vibes and Helm vibes and even simplifying that further. There's a good integration with things like Visual Studio Code and those AI assistants, etc. And so it makes it very easy and fast and convenient to learn. So usually you can train a developer in 20, 30 minutes on this. But the answer is no, you don't need to do that. It's just but frankly, I mean, just looking at our statistics, even though most customers give teams interface choice, 98% of requests that hit our backend are through SCORE.
Yeah. How would App Hub integrate with Humanitec?
Casper, do you have that up? Can we show that real quick? Yeah.
So yeah, here this is, for instance, app integrated with Humanitec. So the answer is our backend is entirely API based, and that means if you are creating something, we can pump this up into AppHub and give AppHub the relevant metadata, and that is pretty much it. Does that make sense, Paul?
Yeah, definitely. So I'll just go a little bit deeper there for a second. So essentially, AppHub is all about registering components. and it's all API driven and it's all metadata driven. So essentially what we did with this integration here was, as part of the definition that you're giving to the Humanitec orchestrator, part of that deployment is to poke the App Hub API with the metadata that application has to register it. So it's kind of like pretty much a service catalog at that point, right? You're registering services.
Absolutely. Yeah.
Nice. How does Humanitec propose to control firewalls, private VLANs between different departments within an enterprise? This would be owned by a centralized team, not an app team.
So the answer is that Humanitec, this is important, doesn't. Okay, so how we propose this here. So we essentially, this is like on the level of the resource definition and the resource spec, how you do this, right? So you say, and so we're always big fans of keeping everything as code. Input code, output code, that makes it nice for disaster recoverability. You can run your, we can run our policy checks on that. And so you would run all of those rules and probably want to have them, and you don't have to, but probably recommend it as infrastructure as code. And so your central team essentially governs those building blocks and components and tells the orchestrator what to use in what context, and then we'll do that. So as an example, and we've been simplifying this a little bit, if a user comes and says they want a Postgres, like they don't want, I mean, they want a Postgres, right? But they actually need a lot more complex things, right? They need VPCs, they need a service account, they need the Postgres itself, they need the user role, etc. And so all of those little things are resource definitions. And the beauty of the backend orchestration and graph-based systems is that they can just read this and then build that acyclic resource graph and say, we have to do this first, then this second, then this third, then this fourth. And we have to treat the output of one as the input to the next and actually compose that. And that gives you that very granular thing, but everything is code and you can maintain and treat it as such. Yeah, that would be the brief answer, but resource management on a platform level is a wide spectrum.
It is. Next question. If SCORE abstracts over deployment environments, technologies, does it take a greatest common denominator approach to features?
Yeah, that's a good way of putting it. Yeah. So you would essentially say, what are the environment agnostic isolated elements, the things that hold true across all environments? Mm-hmm. And that's what you put into your SCORE file. And then you localize this on the environment level. And again, if you think about it as a mathematical model, the job is to express all the variants you need in as few resource definitions as possible. And the better you do this, the easier your estate, you can govern your estate.
Nice. And I see one more question in the chat from Kumar. Can you use this repo that you were showing to clone and develop on top of it?
Yes. Yes. Actually, we launched a new thing today, which I really like. And it's the marketplace. And so the marketplace gives you open source components to build internal developer platforms. And so you can find resource packs for different providers. You can find resource definitions. You can find SCORE implementations. And everything is open source. So go ballistic. On the online boutique, I think this is public. I don't know why it shouldn't be. Usually the demo orgs are all public. So I can just paste this here.
Yeah, and if you're looking for just the generic online boutique, that's on the Google Cloud platform, GitHub org.
Yeah, exactly. So this one is just, we've really just forked this and prepped it with the SCORE files, which is also cool because you can see the before and after and
yeah,
easy it is. Fantastic. Are there any more questions? Anything else we want to cover? Maybe I have a question. Paul, if people want to work together with Humanitec and Google, how do they do this? And we have a couple of very large customers that we're working on and with together and serving in that area. Like, how does that usually look like?
Yeah, I think it flows two ways really, right? So if you have customers that are already engaged via Humanitec, or if somebody reaches out to Humanitec, typically there's a relationship between the two companies that way. But also, if you're a Google Cloud customer, reach out to your account team. Your account team will know how to get a hold of the appropriate people to get those conversations started. My team isn't directly a sales team, so I really can't get involved in that aspect of it, of any contractual type involvement between the two companies. But we are here to help. We are here to smooth the process and develop cool stuff together. So yeah, I would say the best bet is reaching out to your local sales team.
All right. Fantastic. If there is nothing else, we are spot on in terms of timing, exactly 1 minute late. That is amazing. I would want to encourage you. We will send over all the materials. There's PlatformCon coming up. If you're living under a stone and you haven't noticed, and you're not on Twitter, and Luca Cloud bombards you with stuff, then you should know that PlatformCon is coming up. We're expecting over 30,000 people. We have cool things across the world, really. So I'm sure we have something next to you. So if you go to platformcon.com, here we have live days, we have watch parties, we have one in New York. I'm sure Paul will. No, sorry, Paul. Yeah, we have New York, we have Berlin, we have San Francisco, a lot of New York, we have Australia, Austin, Shanghai. So all the hot places, or virtually. And Paul, you're talking. What are you talking about?
Yeah, so I am talking about the reference architecture that you showed earlier, and what that looks like in action. I'm going to have a little synopsis around what it looks like to deploy it, and then what it looks like to actually use it to deploy that online boutique that you showed earlier.
Amazing. I'm going to talk about adoption. I have a fascinating debate with Kelsey Hightower about silos. And then I talk about infrastructure, platform engineering. And Kumar, I'm really surprised that we don't have anything in India. So that sounds like a community activity, putting this together for next year. I'm sure we can count on you. And with that, thank you so much, and see you at PlatformCon, and thank you for your interest.
Thank you. See you guys. Have a great end of the day.
Bye, Paul. Thank you.